This is the first example to do with tilting. So we've got a uniform beam, AB of mass 45 kilograms and length 16 metre, resting horizontally on supports C and D, where AC is 5 metres, CD is 9 metres. When a child stands at A, the beam is on the point of tilting about C. Find the mass of the child. So as always, let's start by drawing a nice clear diagram so we can see what's going on. So we have got the beam AB, which we know has got a length of 16 metres and a mass of 45 kilograms, and because it's uniform, that mass, the weight, is acting in the middle of the beam. So we want 45G right in the middle. We've got two supports, we've got C and D. So A to C is 5 metres, that's going to put it about here somewhere. And A to D is 9 metres. I'm just going to label some of these distances on whilst we're doing this. So something like this is the situation we've got. We've got a child, for some reason, very dangerously standing at A at the end when it's on the point of tilting. Very reckless behaviour. We're not told his mass or her mass, so we're just going to call that mg for his weight or her weight. And we've got reaction forces. So it's tilting, putting a tilting about C. So the key thing about that is that the rod's about to do this. So it's about to lift off away from D. So that means there's actually no reaction at D. Now, you might label it as 0 newtons, but that's not going to really come into it now. However, there is going to be a reaction at C. So this question is going to involve taking some moments. And the idea is that because we've got an unknown force going through C, if we take moments about C, we don't have to include that in our equation. It means that we're going to be able to work out M much more quickly, much more directly. So we have got taking moments about C. We're going to have clockwise to be positive, so the clockwise moment about C, well, that's going to come from the 45G weight of the beam. So I'll put a plus next to that one. The weight of the child is going to push it anti-clockwise, so that would be a negative by that one. And the distance from C to the centre of the rod as well, I ought to label that. That's 3 metres, because rod's 16 metres long. Centre of mass is in the middle, so that's 8. So 5 and 3 makes 8. So when we take moments about C, I'm going to have the 45G force times by 3, subtract the weight of the child, mg, times by the distance 5. And because they're supposed to balance each other out, that must be equal to 0. I can cancel the g's because they're common factors. And then I can just simplify this equation. So 135 take 5m equals 0, and we can quite easily solve that to get m is equal to 27 kilograms, which is then the mass of the child, which is what we wanted for our answer.